Alright, so here we're going to graph a two-variable inequality using an x and y plane. So the equation we have is 2x, or the inequality is 2x plus y is greater than 3. So the simplest thing to do is probably to convert this into slope-intercept form. So we can graph this and then make sense of what's happening. So in this case, we would have to subtract the 2x. So we get negative 2x, and then plus 3, because that's a positive 3. So we could start highlighting this stuff now. Because we have a greater than inequality, we're going to use a dashed line because this is not equal to. Using the same logic, because this is greater than, we're going to shade above the line. So we're going to be looking for values that are larger. So the way we graph this, the y-intercept is at 3, and the slope is at negative 2. So we start at 3. The slope is negative 2 over 1, so we're going to go down 2 over 1, down 2 over 1. We have a dashed line. So we're going to connect these. I'm sorry, this is probably not going to be straight, but you get the point. So there's our line. We have a dashed line. The next part we have to do is shade. So if this is greater, we're shading above the line. So specifically, the y values need to be greater or larger than the values on this line. So if your y-intercept is 3, you need to use y values that are above 3 when x is 0. So hopefully that shows you we're going up. So this is how you would graph that inequality. And we'll do another example that's a little different, so you get the practice. Alright, so we're going to do this one. Same logic. We're going to take this and rewrite it. So we have 3x minus 2y is less than or equal to 12. We're going to subtract the 3x. So negative 2y is less than or equal to negative 3x plus 12. We're going to divide by negative 2. And when we divide by negative 2, this inequality has to flip. Divided by a negative switches the inequality. So now we have positive 3 over 2x minus 6. So here is our line that we're going to be graphing. Our y-intercept is at negative 6. Our slope is 3 over 2. So we're starting at 0, negative 6. And the slope, we're going to move up 3 and right 2. 3, 2. 1, 2, 3, 2. And now let's identify where these pieces are. So this inequality is here, so it's equal to. So we're going to draw a solid line. So let's do that first. So we have a solid line connecting these points. So the next part is the shading. So again, this inequality here is greater than. So just like the last one, we're going to shade above this line. We're going to shade where the y values are greater than or equal to where that line is. So when x is 0, y is negative 6, we want numbers that are larger. So we're going to be going up in this direction. If it's less than, we would go down. And that would be our graph. And that's how you pretty much graph them in slope-intercept. Something fun here, if you wanted to mess around with it. This will give you very nice intercepts. So if you wanted to do this, you could, I mean, you could see it on the graph right now. But if you plugged in intercepts and you plugged in 0 for x, the y value you would get is -6. And if you plugged in 0 for y, the x value you would get is 4. So you can actually plot those 2 points, the 4 and the -6, connect that line using these rules, and then shade it using that as well. So it's a strategy. Some problems are easier to do like that than others, but either way you do it, the graph and the solution should be the same.